Okay, today we're going to solve and learn how to solve one-step inequalities. This is lesson 2.8. So remember what an inequality is. It's a mathematical sentence that uses a symbol, either less than, greater than, less than or equal to, greater than or equal to compare two amounts. The solution set is the set of all values that make the inequality true. So you need to copy this down into your notes. If it's the symbol meaning less than, when we graph it, we will use an open circle because that number is not considered part of the solution set. If it is greater than, it's an open circle as well, not included in the solution. However, less than or equal to, we use a closed circle to show that that number is part of the solution, and a greater than or equal, a closed circle to show that number is part of the solution. So if we want to graph x is greater than 2, we would use a circle, and it would be open. We put it at the 2, right, because 2 is not part of the solution. And all the solution, or all the numbers greater than 2, are part of the solution. So if you want to try it out, what would make it true? If it's greater than 2, it would be 3, 4, 5, or any of the numbers in between. Okay? One thing is if solving an inequality and the variable is on the left-hand side of the symbol, you can look at which way the symbol's pointing. It's like an arrowhead pointing you in the right direction. What about x is less than or equal to 2? Is 2 less than or equal to 2? And then the answer is yes, because of the equal sign part of that symbol. That's why we graph it with a closed circle, because the closed circle tells us that 2 is included. And then the arrow goes left. What about x is greater than or equal to 2? Well, this time, the arrow goes right with a closed circle. So let's give these a try. What would the graph look like for x is greater than 8? If you were asked to draw your own number lines, you could simply draw a number line with 8 and a few numbers around it. We would have an open circle at 8, and it would point to the right. For the next one, x is less than 7. We could probably use the same number line, right? We would have an open circle at 7. This time it would point left for all the numbers less than. For number 3, x is less than or equal to 4. This time it's going to be a closed circle and point left. Free up a little bit of space here. For x is greater than or equal to -3. This time, make sure that you have the correct numbers to the right as it's approaching 0 and to the left, getting farther from 0. It would be a closed circle, and it points to the right. For x is less than -5. It's an open circle, and it points left. And finally, x is less than or equal to 6. And it's closed and points left. If we had one that is, say for instance, -2 is less than x, you realize that we couldn't have it pointing to the left, even though we would look and think that that might be the arrowhead, because you have to see the side of the symbol that the variable sees. And the variable sees the greater than symbol. So in this case, when you have your -2 and your -1, it's an open circle at -2, but all the numbers, so -2 is less than x, it's the smallest number. So the arrow would point to the right because it would have to be all the numbers that are greater than -2, and all numbers greater than are always pointing to the right because that's what the variable sees. So if you're looking from the point of view, right, here's your little eyeball, and you see what the variable sees. The variable sees the symbol, the greater than side of the symbol. So that's why we would make sure that the line, which represents the solution set, would point to all the numbers greater than -2. All right, so the rest of these examples are going to be inequalities that are one step to solve. So the first one, if you want to call it example 1, okay, plus 3 7/9 is greater than 14. So since I am undoing addition, remember from yesterday, we want to use inverse operations. I find the variable. I can treat addition and subtraction one-step inequalities the same way I treated the addition-subtraction equations. So I look to see which side of the symbol the variable is on, and it's on the left. It's being added by 3 7/9, so I can subtract 3 7/9 from both sides. Now, because there's not a fraction to subtract from, I'm going to want to rename the first part of the problem, right? So I'm going to borrow from the 14 to make it a 13, and we'll just make it 9/9 because 13 plus 1 is equal to 14. So now I can take 9 minus the 7 and get 2. 13 minus 3 and get 10, and then I want to bring down my inequality and variable exactly as they were. So in addition subtraction, we keep the symbol the same. When I go to graph it, I apologize, these will be a little bit messier. One thing you can do is, since we know this is going to be 10.2 repeating, sometimes you can, if there's a fraction, just about halfway, and then the symbol, because it's K, it'll go to the right. All right, you can do it above the line, on the line, however you want to do it. But sometimes it's good to label what that is equal to. So in this case, that's, right there, 10 2/9. And it's relatively close to where that would be. So we're going to have to use a little bit of estimation if we get any of these decimal solutions. And again, you could check your work by plugging it back in. You would treat it as if it's an equation to get it to work out the right way. Okay. Example 2. In this case, we're going to undo subtraction. So we just did an addition inequality. Let's do a subtraction inequality. All right, r minus 3 1/5 will be less than a -7 5/6. So we're undoing subtraction, so we want to add in 3 1/5 to both sides. Okay, so this goes to 0. Bring down the r and the less than symbol. Now when you have a negative and a positive, you're not actually adding, but subtracting or finding the difference. And first we have to get a common denominator. So we can write a common denominator of 30. And we're multiplying the top fraction by 5/5 and the bottom by 6/6. So 25 minus 6 is 19 over 30. 7 minus 3 is 4, and so it'll be a negative 4. And again, I could substitute it in to my r and check it out to make sure it's right. When I go to graph this, it's going to be, so we can put, say if this is negative 4, this would be a negative 3, and this is a negative 5. 19/30 is roughly 0.6 with a 3 repeating, so 0.63. So it's going to be a little bit more than negative 4.5, and it's an open circle, and it's going to point left. So again, if you want to put what that's equal to, negative 4 and 19/30, it's right above there so that you know what you're graphing. But just so as long as it goes into the approximate area on the graph, you'll be fine. Okay, example 3. Before we do example 3, I want to summarize for you. For solving inequalities, if we're solving with inverse operations of adding and subtracting, you'll solve using the inverse operation and graph the solution. Now remember, you're graphing the solution at the variable c, so look to the side of the symbol that is facing the variable to decide which way to put your arrow. However, if you're working with a multiplication and a division problem using inverse operations, we'll still use the inverse operation. However, if your solution is found, if you can find your solution by multiplying, so if multiplying or dividing with a positive number, you'll keep your symbol and graph the solution, okay? But if you're multiplying or dividing with a negative number, you reverse the symbol and graph. And if you're wondering why that is, let's take a true inequality. 1 is less than 2. If I multiply both sides by 2, right, 1 times 2 is 2, 2 times 2 is 4, my resulting inequality, 2, is still less than 4. So that's right here, this part, because I multiplied by a positive number. The same would be true if I divided by a positive number. However, let's start over. If I'm multiplying by a negative 2 on both sides, 1 times negative 2, and note that this is not true. However, we can rewrite it to be true by taking negative 2 is greater than negative 4. And if you're not sure about that, think about where it falls on the number line. Negative 2 is to the right of negative 4. That makes it larger. Now, The hard part and the tricky part and the abstract part comes in play when what we're solving for leaves us with a variable in place of one of these numbers. So it's very abstract. And so we have to just double check our work and make sure that if we're multiplying or dividing by a positive number, then we keep the symbol. If we're multiplying or dividing by a negative number, we reverse the symbol to make it true. Okay, so let's take a look at what that looks like. And now we're doing example 3. 1/8 of f is less than or equal to a negative 28. So we learned yesterday that when we want to undo multiplication, we can divide, and in this case, since it's a fraction, multiply by its reciprocal. Notice that what I'm multiplying, this 1/8, was a positive number. Since I'm multiplying by a positive number, I keep the symbol, everything about the symbol. Negative 28 times 8 is a negative 224. Ha, finally a whole number. Makes life easier. So I can graph, getting closer to 0 here and farther from 0 here. And my symbol is a solid circle, and it points to the left. Okay, well, let's try another. Our final example of the day. Let's try a negative 2 5/6 d that is greater than or equal to 6 4/5. So the first thing we want to do with mixed numbers is change them to improper. So I can take 6 times 2, which is 12, plus 5, which is a negative 17 over 6d. 5 times 6, which is 30, plus 4, 34 over 5. Now I'm going to multiply both sides by the reciprocal, negative 6 over 17, and that cancels, times a negative 6 over 17. And again, there's nothing to indicate this other than the fact that we tried it out with small numbers, and we know that when multiplying or dividing by a negative number, I must reverse my symbol. So instead of greater than or equal to, it becomes less than or equal to. Okay, so we reverse the symbol to be d is less than or equal to, and then before I multiply, I want to go ahead and cross cancel because it'll make the math a little bit easier. And so I'll get that this is equal to a negative 12/5. So d is less than or equal to a negative 2 2/5. And when I graph it, I would find that to be approximately 0.4. So I'll find where halfway is, and it's going to be less than or equal to, so closed circle, and it'll point left.